Hey, and welcome back. So before we dive into the code, we need to know how our project structure is, and you need to know some details about the protocols, the architecture, and the media server itself. On the previous tutorials, I had a series which was handling the video conference locally without any media server, and I'll put the links down here. If you watch this image closely, you can see that every client on the video conference would have a direct call with each other. So they'll send and receive the stream one by one. So imagine if you have 4 clients in the video conference, you should have 3 WebRTC peer-to-peer connected to each other. And it means you have to write the local stream 3 times on your socket and receive the remote stream 3 times. It means like 6 times writing and reading the streams. So whenever it goes higher, like the clients goes higher like 5, 6, and 10, the CPU consumption would rise like crazy. I have another series inside my YouTube channel, which is Twitch clone, to teach you how to set up the media server and how to set up a broadcasting or a Twitch clone like application. It's very handy. You have to watch it before you start this tutorial because we use most of the things from that series. I'll put it up here and you can have a shortcut to it. So we use the same structure for deploying the media server. I'm not going to do that over and over again for each series. So let's go back to our architecture of the project. This is the media serverless video conference, but right here there's the MCU or multiple control unit, which is a media server that will do all the heavy liftings. So it means you set up your connection with WebRTC to media server just like a peer-to-peer connection with other clients, but it's from the mobile, for example, with the media server. You publish your stream for the media server. It acts like a man in the middle, and it will distribute your streams to other participants of this video conference room. And it goes the same whenever everyone else is sending you back the local stream. They will be merged in one feed and receive back as like one stream that you'll use it and consume it. But there are some consequences, which is this kind of process is so heavy for such a normal media server and it will consume lots of resources from the server. So now here comes the SFU or single forward unit media server. So how does it work? How we can set up a video conference with SFU server? First, let's break and see how SFU server or single forwarding unit server is working. It's for the publishing or broadcasting server. It means that you only can send the stream within the room and everyone else can receive it. So it's a one-way stream. The connection is the exact same as the MCU server. You will set up the WebRTC connection to the server, like a client to the server for publishing, and goes the same way for the clients which want to receive the stream of the publisher. So I have a diagram here that shows how can we set up the conference using the SFU server. Right here we have the client 1, which is publishing the stream to the SFU server. So there goes one WebRTC connection here for publishing the local stream of client 1, and both of the client 2 and 3 and etc. will do the same. They will publish their own stream to the SFU server. So right now SFU server has the reference of all of the publishers. What we have to do here is each of the participants of this room should have observed the other publishers. As you can see, client 1 is publishing its own and it will receive the stream of client 2 and client 3. And same goes for client 2 and client 3. Here is closer look to check how is the client is participating with the room and other members. On the connection, we will send our stream to the media server and receive back to other streams from user 2 and user 3. it goes the same ways for the other members of the video conference. And it's exactly the same for all of the members inside the video conference. Okay, so it's time to check how is our project is actually working. So we have an Android device or our Android source right now, which is connecting to the backend using the socket IO and also connecting to the media server using the WebSocket. I have implemented both of the sockets protocols, WebSocket and socket IO, to have an experience with both of them. So it's a good practice for you guys. And right here, when our device is connected to the backend, it will receive the initial state of the room. It means that how many publishers are streaming to this video conference. After receiving this initial list, we will set up a WebRTC connection for each of them and show their streams, exactly like that. And then publish our own stream to the backend and send a signal to the room that says, hey, new user is joined. So the other participants will use its link and preview the newcomer video conference participant. So simple as that. Okay, that's it for this video. Let's dive to the code and see how we can set up this beautiful video conference application.